In this lesson, we're going to talk about installing and uninstalling Python packages through a utility that comes along with Python, which is known as PIP, or package installer for Python. I think that's what it means. But before we do that, let's talk about or try to understand what are Python packages and modules. All right, so these are the two keywords that we really need to understand well before we start talking about installing, uninstalling, importing, and stuff like that. So you often, if you have gone through some of the Python code, you often have must have seen the statement in there that import, let's say NumPy SNP or something like that. Right? So this NumPy is actually a package. So what is package? So packages are packages and modules are pre-written code for your convenience. Right? Okay, somebody has already written lots of code for different needs, different purposes, and grouped them together in the form of packages. So modules are Python script files with a .py extension. All right, and packages are a directory structure. Consisting of folders and subfolders. Okay, folders and subfolders to organize all that Python code. All right, so that's more or less what it is. It's nothing too mysterious about these things, and there's nothing too complicated about these things as well. So we all need we all need different kinds of applications and code that doesn't exist in Python, and people around the world thought about that and they wrote third-party libraries or code to solve that. For example, somebody wrote NumPy. NumPy is actually not a standard library that comes with Python. It doesn't come with Python. So Python itself is it doesn't consist of lots of code. It consists of very little code, but the language, the core language itself, does not have too much functionality in it. But it is designed so that people can develop code either in Python or using other languages like C or C++, and make it part of Python, thereby making it very flexible and expandable and powerful. And that's one of the reasons of the popularity of Python. You can expand it to like there's no limit to the expansion, right? That was also one of the reasons of popularity of C and C++ language as well, because C and C++ languages by themselves, the core languages, do not contain a lot of functionality, but it also allow people to write third-party code and attach it as C functions, as C library, as C code, and then you can call those things. So pre-written code that can be used is called by different names in different languages. All right. For example, in C, C++, we call bundles of pre-written code as libraries. Right. So that's it's called libraries. right? In MATLAB, they are called toolboxes, right? In Python, they are called packages and modules. All right, so there's nothing really difficult about or complicated about these stuff. Okay, so they allow the language to expand, and a lot of packages and a lot of modules and packages in Python are written in Python itself, and a lot of them are written in C and C++ as well, because of the reasons of efficiency. So if you write something in C and C++, that's actually a compiled language, and it's known for its highly efficient execution. So when you write something in that language and then make it part of Python, then it's very highly efficient. Okay, so for the sole purpose of efficiency, packages and modules in Python are many times written in C and C++, and sometimes in Python as well. All right. So let's see. So with this aside, we know what modules and packages are. Okay. Every module is a Python script with a .py extension, and packages are folders and subfolders in which modules are assigned. And so when we import, we use a dot notation. Every time there's a dot, it would either mean that we are going to a subfolder or we are accessing a Python file. And then every module may consist of one or multiple functions that can actually be called. Okay. So an example of NumPy, if I give you an example of NumPy, all right. So NumPy consists of functions like, it's a mathematical library. So NumPy is meant for scientific mathematical purposes. All right, so it contains functions like sine, cos, tangent, log to the base e, log to the base 10, square root, exponential function, and so on and so forth. Lots of them. It can further on. It has a random module which contains functions like providing a seed to the random module, getting a random number out of it, and so on and so forth. It also has a string a string manipulation module which is called char, that contains lots of functions that can help you manipulate strings, like adding two strings together, splitting strings into multiple strings, capitalizing strings, or converting them to a lowercase, and whatnot. All right, and it has lots of other modules as well. So let's look at how to install modules. So we go to NumPy. We go to PyCharm, and from there, what we need to do is go to the terminal. Now, at the moment, Python comes with some standard modules already installed in it, okay, like math module, like some other modules. But more powerful functionality is obtained by downloading and installing third-party modules. For example, math module, which is already there in Python, it's installed as part of Python installation, contains some basic functions that you can call sine, cos, square root, and all of these things on single numbers, which are called scalars. But if you need to operate on array of numbers, on vectors of numbers, on matrices of numbers, then that math library or module is insufficient. It doesn't allow that, doesn't have the functionality. Then we need to download and install NumPy. And NumPy is not something that comes with Python. You have to, it was written by somebody else. It's a third-party stuff. So if you try to see if NumPy is already there, import NumPy as, let's say, np, and then hit enter. Then it complains that there's no module in NumPy. That means NumPy is not installed in there. So what you need to do is, similarly, if in your script, that was in the Python console, but in script as well, if I just write the same thing, import NumPy as np, it's not going to be happy, and it just has underlined NumPy with a red line, and if I try to run it, it's going to give me the same error. So what I need to do is I need to install it. So I'll turn that off. I'll go to the terminal, and there's a utility called pip, which is installed as part of Python installation. And I can do the same. I can call the same using the command line interface or the command prompt. I can call pip from here as well, which is the same thing as this terminal. So the terminal provides the same interface. So I can call pip install and let's say NumPy, and press enter. Let's see what it does. It has already downloaded NumPy from wherever on the internet. It knows where to get it from, and it has successfully installed the NumPy library. Let's go to the Python console and check it out. So I'll type the same thing again, import NumPy as np, and sorry, let's import NumPy as np, and there you go. It did not give me any error this time. Okay. In fact, when I start typing np and then I press dot, that means it shows me a list of all the functionality that are available in the NumPy, which you can see absolute, getting a max and min of the vectors or matrices, the inverse cos and inverse trigonometric functions, and so on and so forth. Lots of other things are there, and some, many trigonometric functions are there. Linear algebra functions are there to solve linear algebra systems of equations and other things. So it's a NumPy is a very comprehensive mathematical and scientific library. Okay, so similarly, I can install any kind of other libraries that are out there. If you want to uninstall for some whatever reason, it's easy as well. Just call pip uninstall NumPy. It's asking for confirmation, say yes, and successfully uninstall NumPy, and it finishes up. Okay, so if you go back to Python and repeat the same statement, no, something happened. Let's try it again. It's not installed. Okay, so you go back to the console and try to import NumPy as np, and it start giving the error again that there's no module in NumPy, because whatever we installed, we did the reverse of it. We uninstalled it. Okay, so it's simple. So how does it work? All right, so pip is the we're using pip, which stands for Python package manager, package installer for Python, right? So this is the it's the package management system. It's the Python package management system. All right. It comes with Python and is written in Python as well. All right. How does it find the different libraries that are out there? So it connects to an online repository of public packages that people, they upload their packages, they develop packages and they upload over there. And that repository is called Python Package Index. So it connects to an online repository of public packages called PPI, Python Package Index. Python Package Index. And from there, it searches for that particular package that we type in front of it. And if it doesn't find, it's going to give error. And if it finds it, it's going to download and then automatically install it. So it's a very convenient thing. So any kind of package that you encounter, like some of the common packages that we will be needing for learning Python, basic Python, are NumPy, SciPy. So SciPy is built on top of NumPy, which means it calls NumPy functionality, but expands it further on. So it's also a scientific library, and it provides more functionality than NumPy does. All right. So we may need matplotlib, which is a package or a module or a library for giving the convenience of drawing different kinds of plots. Okay. So and if you're into, so these are enough for some basic Python stuff. But if you want to learn data science, then you also probably need pandas. If you're learning machine learning, then there are so many different kinds. There's scikit-learn. There is TensorFlow. There's Keras. All right, these are some of the popular ones that are out there for machine learning. So that's one of the reason of popularity of Python is it's so flexible. Multiple people have developed different libraries for the same application, and we can develop our own library for whatever reason we like, for mathematical computation or for machine learning, and we can upload it. And if you feel good about that, we can upload it onto the public repository. And if people find it useful, they can start using it.